Everyone, welcome to this video where we discover different privilege escalation scenarios on a tool called CloudGoat. It's very similar to the previous videos that I created. I was using Bishop Fox, I am vulnerable playground. In here, I'm using CloudGoat by Rhino Security Labs. So it's a super cool one. There are multiple scenarios and we are going to cover 2 Lambda vulnerable scenarios in this video. First things first, we're going to set up our environment. It's super simple, just few comments that we're going to run. And after that, we're going to jump into the first one, which is an easy scenario on Lambda Pre-Resc. So let's get started with the setting up the environment. All right, we go to the GitHub page for CloudGoat. It also gives a very nice documentation on how to set it up. It also explains what are we working on, what are the requirements, what's this tool created for. So we're just gonna clone the repository on our current working directory, go to this folder. We're gonna just do pip3 install and the requirements.txt file, which has all of the dependencies that we're gonna just install quickly, and then change the privileges for the file, set the permissions. So we should be almost good to go. So I am also going to my AWS account, creating a user here, setting up credentials, just for the purpose of this video. I delete them all after the video, so if you want to try to hack me, just mentioning that. So we're adding an admin user, adding it to the admins group, which has the full administrator access privileges. So we have the user code now. We're going to create AWS access keys, credentials for the user, use cases, command line interface, confirm it, just add the tag here, let's call it goat key, like for CloudGoat. Copy access key and secret access key. We're going to add it to our environmental variable. Under the home directory, there will be .aws folder, and there's a file called credentials. That's the default file for AWS, and we're going to add our credentials there. You can just also write AWS configure. That's another way to also add the credentials. So we're just going to quickly do that. And then there are a few more configurations needed. In my environment, there are some stuff missing with pip3. I'm just going to install these, like the requests. I think the only thing missing at the moment. Yeah, it should work at this point. So we're just going to set up a few more stuff with the profile. Call it default with our current set of credentials. And let's also set this one up for the quick configuration. Then we will be good to go. Perfect. Cool. This was all the setup that we needed. If you want to read more about what are we doing in here, you should. I cannot cover all of it in the first video. So yeah, let's jump into the first scenario. Vulnerable Lambda. This is small, easy setup. This is the page for it. It explains how to start the setup for this scenario and what are the resources for it, how the scenario starts with our user Bilbo, and what is the goal here to find scenario secret. We're going to start with the Bilbo user, list IAM roles. We're going to assume a role, list Lambda roles, assume roles, invoke a Lambda function, and from there exploit and get the credentials secrets with the secrets manager. I'm going to break it down very quickly. First of all, we're running this and it creates a user with the credentials for this user where we're going to add to our credentials file. So we need to create a profile for this user. As you can see, we get the access key, secret key, etc. We're just going to write it as a profile in our credentials file so that we can do exploitation easily later. That's the file that I'm talking about under the home directory. This is the default. I mean, normally you're not supposed to show this to anybody, obviously, but I destroyed the user after this video. So that's the user goat that I created and the credentials for it. So, all right, so we're creating the profile for Bilbo and we're writing access key ID and secret key from here, from this initial setup for the scenario. And just like that, we save the file. Let's see the file content again to make sure that we did not do any typo or anything. Looks good. We have a profile Bilbo now that we're going to use in the rest of the exploitation phase. Cool. Next thing we're going to do is we're going to check the user's name by writing the following command, AWS STS get caller identity, and we are just attaching the profile Bilbo here, which is going to give us the full user name here, cg-bilbo vulnerable lambda, etc. So that's something we're going to use in the next step. So it's important to know that, not just a profile name. If we go back to the walkthrough, it says get permissions for the Bilbo user and then list all the roles. If you go to the AWS documentation, you can also search for it, AWS list permissions for a user, like which command to use. But I'm using it like that, going to the command line interface documentation and choose AWS and then service name IAM. And if you go to the list, it basically shows you the comments, which comments you can use. And since we're trying to list the policies, you need to go to the list category and what do you have there? List user policies. It's very straightforward with AWS documentation. Like literally the English sentence that you put, I want to list the user policies, literally list dash user dash policies. So we did it for this current user and we get the policy name. You can again go back to the documentation for just IAM and logically, what do you want to do with this policy that we got from the listing? We want to get it, right? Like the get policy, get user policy. So this is for the role, get role policy, get user policy. So whichever category you already got in the first comment, basically it's easy to find the next one by just thinking logical. We list the policies, user policies, so we're gonna get it now. User policies, not role or just policy, get user policy. I don't know, it's like a very cool logic that works easily for me. So we attach the profile and also the policy name that we grab from there. There are a few information, username, policy name, the action here, which is STS assume role, so we can assume role. The resources, the following, CG Lambda invoker. There are other actions with the IAM, like a get, list, any actions with the get and list. Also, there are a few more, and the resources on all for these actions. So cool, we grabbed all this information now that we're going to use in our exploitation phase. So we started with that, we list the IAM roles, and now we're going to assume this role because we've seen already that in this policy, STS assume role is the action, and the role is already given there. So STS assume role is not under IAM. You need to go to the STS service, and this is the role that we are going to assume. We can also list the roles here with the list roles command. We're just going to type it like that, AWS IAM list roles. You can look for the options in the command line interface document. Profile is Bilbo. And we can see all of the roles in here. But there are so many, so we're going to grab them to make sure that we can catch it properly. So we're just going to write CG Lambda, just grab the ones with that. And we got two roles like this with the run as well we got. So we're going to try which one is working. In our case, we can check for the role policies. Of course, we're going to list the role policies. So that's the logical comment that we're going to use, list role policies. Again, these are all under IAM, and the role name we can just attach here as the first one we're going to try, and then we're going to see the second one if the first one is not the correct one. And the profile is of course Bilbo. When we do that, there's this policy name, Lambda invoker. And then next thing after relisting is getting the details of it, get role policy, and there are two options that we need to provide, or parameters, role name and the policy name. And we're going to type it down, AWS IAM get role policy. The role name is the same as the previous comment, and then the policy name would be Lambda invoker. We just grabbed in here, and the profile is the same. All right, then we are seeing like the policy details in here, which actions are allowed, on which resources. We're gonna get the role ARN with this previous comment that we run. Let's try the first one. We don't know if it works. Maybe it will be the second one. We'll see. AWS STS assume role, and then the role ARN, role session name, and also we will get a profile. Let's try the first ARN if it's working. And then the role session name, just name it anything, it doesn't matter. The profile is Bilbo. And we got an error message. So I'm assuming that was not the role that I can assume. So I'm gonna try the second one that I got in the list from the list roles comment when we grab the CG Lambda once to filter. So when I write the second one, it does work. Perfect. Then we get the access key and session token now that we can actually add to our credentials for the next steps of the exploitation. We can go to the documentation for Lambda instead of STS or IAM. We can see which kind of comments do we have. So since we want to list the functions, we can just use list functions comment here. And we can see which options are available here. Doesn't seem like there are a lot of options that we need to give. We have to give. So we're going to type the following: AWS Lambda list functions. The profile will be the assumed after assumed profile that we just created in here with the credentials that we got. And you need to specify a region. I always forget that, like literally all the time. I try to cut these areas that I give get an error message because if I forget the region in these videos, but you'll see plenty of time. I always do that. So we're gonna give US East 1 as default, and then we're gonna see the functions. There are some Lambda functions that you're seeing that are coming from the previous exercises from I am vulnerable and stuff, so you can just ignore these. We're just gonna go to the end of the list for the latest created Lambda function, which is coming from CloudGoat. But I kept these here to make it a bit realistic, because in the real world scenario you're not gonna see just one that you're gonna exploit. So you need to go through the list, and we're gonna find the one with the role name. So what we're gonna do next is we're gonna download the Lambda function source code. Let's get the function first for the full details. The only thing we need to provide for this is the function name. We already got this from the previous comment. And then we're gonna put the region and the profile, of course. So this is going to give us the location of the S3 repository for us to download the code. Just scroll down and copy this URL. We're going to get this, we're getting this code with wget, and it's saved as lambda.zip. So we're getting this file with wget. It's a big file, it's a zip file. We can just rename this because it looks quite ugly. Let's move this big file as a.zip, doesn't matter. And let's unzip this file to see what kind of content do we have here. It's a zip archive data. We check with the file comment. Unzip it, that's a quite big file. So let's see the file content. And of course, it starts with main.py, as we know. Main.py is the code with the main function. Since the execution will start from the main function, we're gonna have it a look. We're seeing that it imports a database. We're seeing some comments here with the DB policy names and insert DB insert, and then we are trying to understand how it's called in the SQL query by reading the source code. It seems like in the query it asks for two parameters. One of them is policy names in an array, and the other one seems like the username from the code. It seems like the policy names value is just passed directly in the SQL statement, if you see it in the statement line, and we don't see any filtering input validation, which seems like it's vulnerable to the SQL injection. So what we can do at this point is we can create a little policy file, a JSON file that we just pass administrator access policy name, policy in the policy names array, and the username is the current user that we're gonna give. Created this file, but I did not inject any single code or anything to exploit the SQL injection. I'm just trying to see if the syntax is correct with that. When we try to invoke the Lambda function with the following comment, you also need to give the formatting for it as base64, which is given as a hint in the task. And when we read the output, it says that it's not an approved policy and don't cheat. Okay, so we're on the right path. It's just that we need to exploit the SQL injection and give a comment for the rest of these query. So we're just gonna give it very basic, any SQL injection scenario you can think of, given a single code, and then comment out the rest, which is, I think, checking if the SQL statement is true or false. So we don't need to check this at this point. We're just gonna send the same comment to invoke the function, and we don't get any error messages. And says all managed policies were applied as expected. So seems like the SQL injection worked, and we just invoked a function which added administrator access policy to our user. We're gonna check for Bilbo profile with the list attached user policies to see if administrator access is added to our user's policy as attached policy. Let's see. We're given the username, the profile, the region, the classic things that we've done in the beginning of the attack. And as you can see, administrator access is attached to our user now. Next thing we're gonna do is we're gonna get the secrets from the secrets manager. First, we're gonna list it down. You can check the documentation for secrets manager as well if you're not familiar with it. But the comment that we're gonna use is AWS Secrets Manager get secret value. We need to give the secret ID, the ARN here, and the profile, which is Bilbo, that administrator access profile policies attached to it. So here we go. We got the secret string here, the name, the ARN, and we exploited it successfully in this way. Super cool. All right, the next scenario is, I think that's the third scenario, not sure in the list. Anyway, it's called Lambda Peresque. In the same way as the previous one, we're gonna run this comment to start the initiate the scenario, create the users and any other resources that's needed. We're gonna run this comment, and at the end of this comment, we're gonna have a profile. We're gonna have a credentials. That's the scenario. We need to acquire full admin privileges at the end. We're gonna start with an IAM user Chris. We said this is like a not high privileged user. We're gonna identify a Lambda manager role, which has full Lambda access and pass role permissions. We're gonna assume this role using Chris. Then we will identify another role with like debug privileges and also have full administrator access. From there, we're gonna create a Lambda function, pass this debug role, invoke the function to achieve full admin access. It also gives a walkthrough, which is like the full English sentence for what we try to achieve, which is also easier for us to figure out which command we need to use. It's a very much try and error kind of situations, but yeah. So we need to add the credentials. It's coming from the previous exercise we just done. We can delete these. We're not using it anymore. So we need to add the needed profile. We can call it Chris, for instance. And then the The access key ID and secret access key is coming from our initial setup. So as the first step for the enumeration, we can check for the attach policies, manage policies. So we need to enumerate this user. I'm not using an automated tool right now. In the next exercises, we will do that. So let's do it manually. AWS, IAM. The next step is list user policies or list attached user policies. These are two options for us to check. Attach policies, inline policies, manage policies. So let's see. And now AWS IAM. First of all, we're going to get the full username, AWS SCS get caller identity. We're given the profile. That's like always the first step to grab the username. That's cool. We got it. Chris Lambda Prevesk, and then we're using that username. Then we can list for the profile, list for the policies. Then we're writing the command AWS IAM list user policies, or the other options list attached user policies. For both of them, we're not gonna give the username that we just got from the first command, SS get caller identity, and we need to attach the profile, which is Chris that we just created. And there's no policies. Cool, no inline policies. The other option is if there are any managed policies with list attached user policies. That's what we're gonna check the next. That's what we're gonna check next. So just update the comment a bit, but you can also check the documentation if you're not familiar with these comments. So obviously we are listing, and IAM. Under IAM, we're listing, and we were using list user policies. Now we are gonna use another option, and you don't know it. What you're gonna do is you're gonna go through all the list comments, which one is looking similar. List something user policies, list attached user policies. So if you're not familiar with it, that would be great help in the command line interface documentation. And we will find some managed policies, the policy name. We can get the details of this policy. We can also write it down, like all the comments that we run so far, like just as a reference to you if you're confused. We first enumerated the user. We checked for the inline policies, the managed policies. So if you're like confused what's going on, that's also like a good way to see it. We check for the managed policies. And I'm also writing the username here, which is going to be useful to check out later. Policy ARN, policy name, these are also going to be useful in the next comments. Okay, after running this comment, we're getting the policy details, the version for the managed policy that we found. You can also read the policy content by typing get policy version. We already get the default version, so we can see the content of it in this way. So it will be AWS IAM get policy version. Version ID would be v1, and then the policy ARN that we just gave in the current comment already. Version ID as v1, and we will also update the comment from get policy to the get policy version. And let's note these down as well in case you're like confused what we're doing and you want to catch up. Just pause the video and see which comments we used. First we got the get policy, and then we got the get policy version with the version that information that we got from the previous comment. So these are like the enumeration on the policy. Cool. So what do we have here as the action? STS assume role. With the IAM, any actions with list and get. Resources on all. Version ID is given here. So okay, so it basically tells us that we can assume role on any resources. So it's good to know. So we can basically, we have the permissions that allow us to assume another role, any role that has trust relationship with Chris. So we can look for other roles that may have a trust relationship with Chris. So for that, we need to use a command called list role. There will be a lot of them, and it will, if you like, for instance, make grab Chris, that would be one way to filter it down. But when you say grab Chris, it will just bring the lines that mentions Chris in it. And then we cannot actually learn about which policy name, which role name, all of this information that will not come if you just grab Chris. So grab command, like Unix command, is having an option for you to just filter out the previous specific amount of lines and the before. So for that, you're using -b before, -a or -b -a for that. So which will list all the roles that are useful for us. And after that, once we find a useful role for us, we can assume that has a trust relationship with Chris. We can list attach role policies with the found role name that we just found here. That's trust relationship with Chris, to also see the manage policies. We can also check the permissions on the policy. We will write get policy, and then the policy name or policy ARN is given in here already, using the role that we're going to assume. And the version is 1. We can also get the content of the policy by just giving version ID v1, and also the comment would be get policy version for this end. Another comment, I am get policy version ID is v1. It has Lambda any actions, and also I am pass role on any resource. So that was the Lambda manager policy that we were talking about in the original documentation. So first of all, we're gonna assume the role with this role that we just found. After we filtered with the name Chris for the trust relationship that we were looking for. Here we go. We gave the role name in here in this comment, for instance, or you can go back to the filtering that we done, that we found this role that has a trust relationship with Chris. So we're given the role ARN, and then the role session, doesn't matter, just give anything, which will give us credentials. After that, we can just add it to our credentials list. So the next thing we need to do is create a Lambda function that will attach administrator access policy to our Chris user. And we're going to do it by using the assumed role, like Lambda manager role. We're going to check for these roles that was mentioned in the documentation, that is debug something role that has full administrator access privileges, if you remember that. We're seeing it in here, the role ARN, and we can see which permissions are attached to this user, because in the documentation was mentioning that that's a user with full administrator access privileges, if I remember correctly. So we can just check it out quickly if that's the user that's been talked about. I mean, there's no other user with debug, but let's assume this is a real-time scenario, real life scenario, so you want to actually be sure. So you're just going to check for the profile Chris. We're going to check the attach role policies. We're going to list them down for the current role that we found, the debug role. We're going to find the policy name, and from there, as you can see, it's the AWS Managed Policy Administrator Access already on this debug role. So we're going to create the Lambda function. Next, we're going to create a Lambda function. If you're not familiar with it, just check it out on ChatGPT or check online for like how to write Lambda function, or like simplest template, or you can even search for it, like how to add a user to administrator, how to attach administrator access policy to a user. Like it's the most simple one probably. I'm going to call it lambda.py. Just go into ChatGPT, ask that. Basically create a Lambda function that attaches administrator access policy to a user. Just create the code from here, but we need to update it a bit because it has the it does the error handling, exception handling here, so we don't need that. Just simplify the code. What we need is the IAM client. First create an IAM client, like the initialization phase, and then give a username, which is the user that we are trying to attach administrator policy to. Post errand is already given in here, so you don't need to mention that. Delete the comments so it's easy to read. I deleted all the parts that makes exception handling. We don't need that. I'm just gonna add the username in here. Also, let's correct the indentation because it looks it doesn't look right. First, add the username here. Delete this comment and correct the indentation, which should be good to go. Very simple function here. Attach user policy, and the username we already mentioned. We already created, defined in here. Post errands already given. Close the parentheses, and we're good to go. And we also need to return the value for the variable, and let's set it up first. Call it response, and then return it at the end for the function. That's a very simple Lambda function to attach a administrator access policy to a user. So super simple one. Next thing we're gonna do is, if we are gonna create the function, we need to change the file extension to zip. So we can just zip this file into a lambda.zip file, for instance, and add the Python file in it. And then we're going to create the function, AWS Lambda, the service name, and then the comment create function. Function name, call it whatever you want, doesn't matter. And then the runtime, I think I'm running Python 3.11, but you can check it with Python 3 -- version. And then the role would be this debug role that we found. Where was it? Here we go. Just copy paste that one. But we need to give the ARN for it. So yeah, let's copy paste this one. And then the handler would be the file name for the Python code dot function name, which is Lambda handler, if I remember correctly. Where is it? Here we go. So the code name lambda handler. Here we go. And then the zip file, we're going to attach it with the syntax file B, and then the file content with the current working directory we attach here, lambda.zip. We need to give the region and the profile as well. The region, we can give the default US East 1, and the profile would be the one that we added the latest, like the assumed role, like the Lambda manager one. Perfect. After creating the function, we're going to invoke it, which will do the work for us. The function name that we just specified, the output can be like written in an output.txt file. Give the region and the profile as well. Very straightforward. If it doesn't give any error messages, then we're good to go. We can also read the output.txt to see that there are no error messages. Everything is good. And we don't get any error messages. Set this code to 100. Read the output.txt file. Everything looks good. So we can check the attached policies for the Chris user now to see administrator access added to it. If that's the case, which should be the case here because we invoked the function and it didn't give any error, so we would finalize the exercise in this way. Let's add the username here with the Chris. Where was it in the first comment? Here we go. And you can see the attached policy administrator access in here. Another exercise, we exploited Lambda misconfigurations, and here we go. I hope that you enjoyed the video. As a summary, we created we solved 2 scenarios on 2 different Lambda privilege escalation scenarios, but we used different services, not just Lambda, which was cool, like SES, IAM, Lambda, etc. So I hope that you liked the video. Next videos will be covering other CloudGoat scenarios. There are a lot of them, and some of them are easy, like the first exercise we done. Some of them are like medium severity, like this one, and there are also hard ones, like longer scenarios that are very similar to like the real life scenarios, I think, and I really enjoyed working on these. I hope you learned some stuff as well. Drop a comment and see you in the next video. Cheers, guys.